The invoice on the conference table read $8 million and 3 years of failed attempts. 31 engineers. 4 continents. 1 engine that had not made a sound since the day it arrived broken at the factory floor. The company that built it could not fix it. The man who fixed it arrived on a Saturday morning in a truck with a cracked windshield, carrying tools in a plastic bin he had bought for $19 at a garage sale 3 weeks earlier. He was not an engineer. He held no certification from any institution the factory would have recognized. He had a 9-year-old daughter named Lily who was asleep in the passenger seat with her seat belt still on when he pulled into the lot. He fixed the engine before sundown. What the factory's 31 engineers had missed was not complicated. It never is. Stay with this story until the very last word. Because what this man found inside that engine will change the way you think about expertise, about institutions, and about the kind of knowledge that never gets a title on a door. The Harmon Precision engine facility sat on 40 acres of flat Indiana land outside a town called Millbrook, the kind of town that existed primarily because the factory did. 3,000 people worked inside its main building on any given weekday. The parking lot filled before 6 in the morning. The cafeteria ran 3 shifts. The health insurance plan was the best in the county by a margin wide enough that people stayed in jobs they had quietly outgrown simply to keep it. Harmon Precision did not build consumer engines. They built one specific category of propulsion system, high-output industrial turbines used in deep-water extraction platforms, designed to operate continuously at extreme pressure for years at a stretch without maintenance access. The kind of machinery that, once deployed, could not be retrieved easily for repairs. The kind that had to work the first time and keep working long after that. Their reputation was the only product they truly sold. Everything else followed from it. Richard Harmon, the company's chief executive and the grandson of the man who had started the operation with 2 lathes and a corrugated metal building in 1961, understood this more completely than anyone who worked for him. He was 61 years old, precise in his movements, conservative in his language, and genuinely incapable of tolerating the condition the company now found itself in. The engine designated PT-7 had arrived at the facility 3 years and 4 months earlier, returned from a decommissioned platform off the Norwegian coast after exhibiting a failure pattern that none of the platform engineers had been able to categorize. It had not exploded. It had not seized. It had simply stopped producing output in a way that left every diagnostic instrument pointed at it reading normal. A running engine that produced nothing. Every internal measurement within specification. Every external reading confirming the engine was, by all available evidence, operational. Except that it was not. In the 38 months since its return, Harmon Precision had assembled and disbanded 4 separate internal engineering teams. Had contracted with 2 independent firms from Stuttgart and 1 from Seoul. Had spent $400,000 on a scanning system designed specifically for this class of turbine. Had filed 3 inconclusive internal reports and 1 formal notation to their insurance underwriter acknowledging the engine's unresolved status. The total expenditure had crossed $8 million on a Tuesday morning 3 weeks before this story begins, when the 4th team's project lead submitted his final report and quietly tendered his resignation on the same day. The report concluded that the PT-7's failure was mechanically inexplicable given available diagnostic data and recommended the engine be decommissioned permanently and the loss absorbed. Richard Harmon had read the report twice, set it face down on his desk, and not spoken for 11 minutes. Then he had called his assistant and said to clear his Thursday. Caleb Durst lived 14 miles from the Harmon facility in a house that needed a new roof and had needed one for 2 years. He was 38 years old. He had worked in industrial machinery for 15 of those years, starting on the floor of a pump manufacturing plant at 22, moving through 3 companies in the years that followed, accumulating the kind of experience that does not appear on a resume because most of it happened in moments between shifts, in problems that arrived without manuals, in equipment that no certification course had ever covered because it was too old or too specific or too broken to be worth a curriculum. His daughter Lily was 9. She had her mother's eyes and her father's habit of going completely silent when she was thinking hard about something. Her mother, Dana, had died of a brain aneurysm 22 months earlier, on a Wednesday afternoon in March, which had been an ordinary Wednesday afternoon until it was not. Caleb had not taken a day off after the funeral because there was nobody else to pay the mortgage, and Lily needed her school clothes and the roof needed fixing, and none of those things paused for grief. He drove a truck with 212,000 miles on it and a crack in the windshield that had started as something small near the bottom passenger corner and grown incrementally over 14 months into a line that crossed nearly the full width of the glass. He had not replaced it because the truck still ran and a new windshield cost $400, and there was always something the $400 needed to be before it could become a windshield. He worked currently as an independent maintenance contractor, taking jobs from 3 industrial clients on a rotating basis and occasionally picking up diagnostic work on agricultural equipment for farms in the county. It was not glamorous work. It paid reliably, which mattered more than glamour when a 9-year-old needed school supplies and the power bill arrived in the same week. On the Saturday morning this story begins, he had been hired for a completely different reason. He had not been hired to fix the PT-7. He had been hired to replace a section of corroded drainage pipe in the maintenance corridor running alongside the turbine testing bay. The maintenance coordinator who had brought Caleb in was a woman named Sheila Tran, who had worked at Harmon for 11 years and operated the facility's contractor scheduling with the quiet efficiency of someone who had stopped waiting for acknowledgement and simply focused on keeping things running. She had called Caleb because he was reliable, because he charged a fair rate, and because the drainage pipe had been corroding for 6 months while the engineering teams rotated in and out of the bay beside it, and nobody with a budget had found time to address something as unglamorous as a drainage pipe. Caleb arrived at 6:45 that Saturday morning with Lily asleep in the passenger seat and his tools in the plastic bin on the back seat. He had brought Lily because the neighbor who sometimes watched her on short-notice jobs was visiting family in Columbus, and Lily had informed him the previous evening that she did not mind coming along as long as she could bring her book. She had brought 2 books. Sheila met him at the side entrance with a badge and a brief explanation of where the corroded section ran and what it connected to. She told him the turbine bay alongside the corridor would be empty. The engineering team had formally disbanded their project the previous week, and the bay had been cleared pending a decision from upstairs about the engine's future. Caleb signed the contractor log, handed Lily a granola bar from his jacket pocket, and told her he would check on her every 45 minutes. She told him she would be fine and opened her book before he had turned around. The drainage pipe ran along the eastern wall of the maintenance corridor for 31 feet before connecting to the facility's main outflow system. The corroded section was 18 feet of it, concentrated in the middle third where a slow leak in the ceiling above had been depositing mineral-heavy water directly onto the pipe housing for what looked like several years. Caleb worked through it methodically, cutting the damaged section, cleaning the connection points, fitting the replacement length, and sealing both joints with the unhurried precision of a man who had done this particular type of work enough times to move through it without rushing and without wasting motion. He finished the first joint at 9:17 and stood to stretch his back. The door to the turbine bay was 20 feet down the corridor, standing slightly open. The way doors in empty facilities are often left when nobody expects them to matter. He could see the PT-7 from where he stood. He did not intend to go closer. He had not been contracted for anything in that room, and he was not a man who involved himself in things that were not his assignment. But the engine was directly in his sight line from where he was working, and Caleb Durst had spent 15 years developing the specific occupational habit of watching machines the way other people watched weather. Automatically. Without deciding to. He noticed something in the first 4 minutes without meaning to. He went back to the pipe. He noticed it again at 9:41 when he stood to retrieve a fitting from his bin. By 10 o'clock he had finished the second joint and was applying the sealant cure when he set down his brush, stood completely still for a moment, and looked at the PT-7 directly for the first time since arriving. Then he picked up his plastic tool bin and walked to the bay door. He did not touch the engine. He stood at the threshold and looked at it from the doorway for close to 4 minutes, hands in his jacket pockets, the same way he stood in front of any machine he was trying to understand before he committed to an interpretation. The PT-7 was approximately 11 feet tall and 14 feet in diameter at its widest housing point. It sat on a reinforced mounting platform bolted to the concrete floor. Diagnostic ports ran along its accessible side panels in a configuration he recognized as standard for this class of turbine, though he had not worked on this specific model before. The bay smelled of machine oil and something faintly metallic that suggested recent electrical activity, recent meaning within the last several weeks. He looked at the access panel on the turbine's lower left quadrant, the one a technician would open first when beginning an internal inspection. It was seated fractionally wrong. Not dramatically. Not in a way that would appear in a photograph or register on a systems check. A few millimeters of misalignment along the lower edge, the kind of thing you noticed only if you were looking at the physical object rather than the data it was generating. Caleb walked back down the corridor, finished the sealant application on the second joint, and checked on Lily. She had moved from the first book to the second and informed him that the first one had a disappointing ending. He told her he would be another couple of hours. She told him that was acceptable. He went back to the bay. He called Sheila at 10:38 and asked one question. He asked whether anyone had contacted her about authorizing a brief inspection of the PT-7 prior to its decommissioning. Sheila said nobody had contacted her about anything related to that engine in 2 weeks. Caleb asked whether there was anyone he should speak with before entering the bay to look at something. Sheila was quiet for a moment. Then she said the bay was technically unassigned pending the executive decision. She said she was going to make a phone call and she would get back to him in 10 minutes. She called back in 7. She said whoever needed to authorize it had authorized it. She said he had 30 minutes and she would need a written summary of anything he observed. Caleb said that was fine. He picked up his tool bin and went in. He opened the lower left access panel with a standard panel key from his bin, the same type used across most industrial turbine housings of this generation. The panel had been opened before. Recently. The interior edge showed contact marks from multiple prior entries. The internal fasteners showed the particular wear pattern of components that had been removed and replaced repeatedly, the kind of microabrasion that accumulated over dozens of entries rather than standard maintenance intervals. He noted this without surprise. 31 engineers over 3 years would have opened this panel a considerable number of times. He shone his inspection light into the housing and looked. He looked for a long time. Long enough that the light's battery indicator dropped from full to 3/4. He set the light down. He sat on the bay floor with his back against the mounting platform and looked at the ceiling for 60 seconds, which was how he processed something that required thought before action. Then he went back to his truck. The plastic bin he had bought at the garage sale for $19 contained a set of general-purpose socket wrenches, 2 torque instruments, a voltage meter, an inspection light, a fiber optic diagnostic scope he had purchased second-hand from a medical equipment liquidation 4 years prior and adapted for industrial use himself, and a thermal imaging attachment for his phone that he had bought refurbished for $62. None of it was factory-spec equipment. All of it worked. He carried the bin back into the bay, set it beside the access panel, and began. What Caleb found inside the PT-7 in the next 4 hours was not complicated. It was not complicated in the way that the most expensive problems rarely are. Once someone with the right kind of attention finally stops reading the instruments and looks at the actual object. The PT-7's internal pressure equilibration system relied on a sequence of 7 ceramic composite valve seats arranged in a radial configuration around the engine's central output shaft. These seats were designed to maintain an exact tolerance gap of 0.003 inches at operating temperature, allowing the turbine to sustain its pressure differential during continuous output operation. The 4 external engineering teams had measured the valve seats. All measurements had confirmed the seats were within specification. What none of the measurements had accounted for, what none of the scanning systems had been positioned to detect, was a phenomenon Caleb had encountered once before, 7 years earlier, in an agricultural pump system on a farm 12 miles from his house. A phenomenon with a technical designation he could not have produced from memory but whose signature he recognized the way a person recognizes a voice they have not heard in years. Thermal shadow compliance failure. At ambient temperature, the ceramic valve seats measured correctly. Every instrument confirmed it. The gap was 0.003 inches. The system appeared sound. At operating temperature, a specific combination of heat distribution from the engine's ignition sequence and the particular alloy composition of the shaft housing caused the metal surrounding the ceramic seats to expand at a rate that the seats themselves could not fully accommodate. The gap did not close catastrophically. It shifted asymmetrically, wider on one side by a fraction too small for standard measurement at temperature to detect, because standard measurement at temperature required the system to be running, and the system would not run. The engine could not reach operating temperature because the valve gap was wrong. The valve gap could not be measured correctly because measuring it required operating temperature. Every team had walked into a diagnostic loop that the engine's own architecture had made nearly impossible to exit using standard procedure. Caleb had not used standard procedure. He had used a fiber optic scope, a thermal imaging attachment, and 15 years of knowing that machines told you what was wrong if you looked at the physical object instead of the data it generated. He found Sheila at 11:53 and told her what he had found in the same methodical sequence he used for everything, what he had observed, what it indicated, what the fix required, and approximately how long the fix would take. Sheila looked at him for a long moment. Then she called upstairs. Richard Harmon arrived in the bay at 12:31, still in the weekend clothes he had been in when Sheila's call reached him at home. He was followed by the facility's head of engineering, a man named Paul Greer, who was 54 years old, had a doctorate from MIT, and was not accustomed to Saturday afternoon summons from maintenance coordinators about drainage pipe contractors. Caleb walked them through it at the open access panel. He used the fiber optic scope to show them the valve seat configuration at ambient temperature. He showed them the thermal imaging readings at 3 different points along the shaft housing. He explained the expansion differential in plain language, without technical vocabulary he did not have and without apology for the vocabulary he was using instead. Paul Greer crouched beside the access panel and looked through the scope for 2 minutes without speaking. When he stood up, his expression carried the specific quality of a man who has just understood something he should have understood earlier and is deciding how to sit with that. Richard Harmon looked at the scope. Then he looked at Caleb. He asked how long a fix would take. Caleb said if he had the right shim stock and access to a machine lathe, he could have a corrected seat profile fabricated and fitted by early evening. He said the shim specification was standard industrial grade, nothing proprietary, nothing that would require factory sourcing. Harmon asked whether the facility had what was needed. Paul Greer said yes. Quietly. Without elaboration. Harmon looked at Caleb for a second longer than the question required. Then he said, "Do it." Caleb called Lily at 12:45 and told her he was going to be longer than he had said. She asked if he had found something interesting. He said yes. She asked if it was the kind of interesting that made him go quiet when he was thinking. He said yes. She told him she had finished both books and asked if there was anywhere to get lunch. Sheila took Lily to the cafeteria and came back with a report that the child had eaten a full plate of food, asked the cafeteria staff 2 questions about how industrial dishwashers worked, and was currently reading the safety manual she had found on the waiting room table because she had run out of other things to read. Caleb worked through the afternoon without stopping. The shim fabrication took 2 hours on the facility lathe, a process Paul Greer observed from the doorway for the first 40 minutes before pulling up a stool and sitting down without comment. He watched the way a man watches something he is trying to understand, with the specific attention of someone who has spent a career measuring outcomes and is encountering a method he did not account for. He did not offer help. He did not ask questions. He watched. At 3:40, Caleb carried the fabricated seat corrections back to the bay, set them beside the access panel, and began the fitting sequence. At 5:12, he closed the access panel and stood. He looked at Paul Greer and said he was ready to run a startup cycle if someone could authorize it. Paul Greer authorized it himself. Not with drama. Not with the kind of mechanical crescendo that announces itself across a building. It started the way a correctly assembled machine starts, with a rising, even, sustained output that settled into a frequency so consistent and so clean that the testing bay's own monitoring system flagged it as a calibration anomaly for 11 seconds before confirming the reading was accurate. The engine was running. The output pressure climbed to operational range in 4 minutes and held there without deviation. Richard Harmon stood in the bay doorway with his hands in his pockets and did not speak for a long time. Paul Greer sat down on his stool and looked at the monitoring screen. The expression on his face was not embarrassment exactly. It was the particular quiet of a person absorbing the distance between what an institution had concluded and what a man with a $19 tool bin had found. Sheila stood beside Caleb and said nothing, because nothing she could have said would have been the right size for the moment. Lily appeared at the bay door holding her finished granola bar wrapper and her empty juice box and asked her father with complete seriousness whether he was done yet because she had read the entire safety manual and needed something else. Caleb looked at her for a moment with the expression of a man who has just done something significant and needed the reminder that the most important thing waiting for him had been sitting in a chair the whole afternoon. He said yes. He was done. Richard Harmon asked Caleb to come to his office before leaving the building. The office was on the second floor with a window that looked directly down into the turbine testing bay. Harmon sat across from Caleb in a chair that had not been designed for a man who looked as tired as he currently did, and he placed both palms flat on the desk the way a person does when they are about to say something they have been thinking about for longer than the conversation has existed. He said he wanted to understand what Caleb had seen that 31 credentialed engineers had not. Caleb thought about the answer the way he thought about questions that deserved a real one. He said it was not about what he had seen. It was about where he had looked. He said every team that had come through that bay had started with the diagnostic data and worked backward toward the physical object. He said he had started with the physical object because that was the only place he knew how to start. He said the access panel was seated wrong. That was the first thing. Not by much. But enough to tell him the interior had been opened and reseated many times. Which told him people had been looking in the right location but finding the right answer difficult. Which told him the problem was probably something the instruments were not designed to catch. He said everything after that was just looking carefully. Harmon asked where he had encountered thermal shadow compliance failure before. Caleb said on a water pump on a soybean farm. He said the farmer's name was Ed Marsh and he was 72 years old and had been about to spend $14,000 on a pump replacement before Caleb found a $40 bearing seat that had been expanding asymmetrically every summer for 6 years. Harmon looked at him for a moment. Then he asked what Caleb had charged Sheila for the drainage pipe job. Caleb said $320. Parts and labor. Harmon said that was not what he was going to pay him. The figure Richard Harmon wrote on the contractor addendum was not a number Caleb had prepared himself for. He looked at it for long enough that Harmon asked if there was a problem. Caleb said there was no problem. He said he wanted to make sure he was reading it correctly. Harmon said he was reading it correctly. The number reflected 4 things, Harmon explained. The resolved repair. The 3 years and $8 million the company would not be spending any further. The contractual value of the PT-7 returning to service. And one additional item Harmon named specifically and without ceremony. The cost of having the right person do the work rather than the right credential. He slid the addendum across the desk. Caleb did not sign it immediately. He set his pen flat on the desk beside it and asked one question first. He asked whether Harmon Precision had other equipment in the facility that had been assessed as unresolvable and set aside. Harmon's expression shifted slightly. He said there were 3 other pieces of equipment in that category. Caleb said he would like to look at them before he signed anything. Harmon looked at him for a long moment. Then something in his face settled, the way a man's face settles when he has been reminded of a quality he had forgotten to look for. He said Monday worked for him if it worked for Caleb. Caleb said Monday worked. He signed the addendum. On the drive home, Lily sat in the passenger seat with her seat belt on and her second finished book in her lap and asked her father what the engine had been worth. Caleb said a lot. She asked why nobody had been able to fix it. He thought about that for a moment. Long enough that she looked up from her book and waited, the way she did when she knew he was finding the real answer rather than the easy one. He said sometimes people with a great deal of knowledge about how something should work stopped being able to see how it actually worked. He said the 2 things were not always the same thing. He said that was not a failure of intelligence. It was a failure of where you started looking. Lily considered this with the particular stillness she reserved for things that required actual consideration. Then she asked if that was why he always looked at the thing first before he looked at any of the papers about the thing. Caleb glanced at her. He said yes. That was exactly why. She nodded once, with the satisfied expression of a person whose hypothesis has been confirmed, and went back to her book. Outside, the Indiana flatland ran past the cracked windshield in long, darkening panels. The truck moved steadily through the last of the evening light, carrying a man who had not asked to be in that building, had not arrived with any plan beyond a drainage pipe, and had spent a Saturday doing what he had always done. Looking at the actual thing. Not the reports written about it. Not the credentials assigned to assess it. The actual thing. 3 years. $8 million. 1 weekend. $19 worth of tools. The engine that an entire factory could not start was running now, steady and clean, in the building 14 miles behind them. And the man who had started it was driving home to make dinner. If stories about quiet people doing what institutions couldn't, and the tools they carry that no amount of money can replace, if those are the stories that stay with you, stay close to this channel. Because there are more of them. And they are all true in the ways that matter most.